So problem number 1, the wavelength W of a wave of a certain frequency varies directly as the velocity v of the wave. So W varies directly with v, and W is 60 when v is equal to 15. Divide both sides by 15. 4 equals k. So our equation would be W equals 4v. So we would be getting v and W. We know that when v is 1, W is 4. When v is negative 1, W is negative 4. Is that enough points to go? Yes, because when it's 0, it's 0. So we get our first point, 0, 0. Remember, direct variation is going to be a line through the origin. When v equals 1, 2, 3, 4, W is 4 and v is negative 1. 1, 2, 3, 4. We get our graph like that. Direct variation is going to graph as a line through the origin. Okay? One down. Okay, so the number of hours it takes a crew to set up the stage for a U2 concert varies inversely with the number of crew members. Okay, so if it's inverse variation, the hours varies inversely with the number of crew members. So we have our algebraic expression or equation set up. So if 20 crew members set up the stage in 3 hours, that would be 60 equals k. Okay, we got to figure out how long it would take with 12 crew members. So hours would be equal to our k value, 60, 12. So this would take 5 hours. We're going to so these guys say simplify and state the excluded values. So for every one of these things, our first thing we are always going to do is factor. So for this problem, 4x squared minus 2x over 4x minus 2, we can pull out our greatest factor, which is going to be 2x, which gives us 2x minus 1 in the numerator. We can pull a 2 out of here in the denominator, and also gives us 2x minus 1. This is multiplication. X squared plus 16x plus 64 factors as x plus 8 times x plus 8 over x plus 8. Our excluded values, those would be the values that make the denominator equal to 0. You take each factor contained in the variable, so 2x minus 1 cannot be 0, so x cannot be equal to 1/2. X plus 8 also cannot be 0, so x cannot be negative 8. Now we just start canceling terms, okay? This 2 cancels this 2. 2x minus 1 cancels 2x minus 1. One of these x plus 8s cancels the x plus 8 in the denominator. So we are left with x times x plus 8. All those terms are left in the numerator. With these restrictions, x cannot be 1/2 or negative 8. Or you could multiply this to x squared plus 8x. Either one of these are fine with the same restrictions. X can't be 1/2 or negative 8. Problem number 4. Again, we're going to factor the numerator b squared minus 3b minus 4. Factors as b minus 4 times b plus 1. The denominator, b squared minus 2b minus 3, factors as b minus 3 and b plus 1 times, again, we're going to pull out the greatest common factor of 4b minus 12, which is 4 giving us b minus 3, and 4 is already factored. So in the denominator, the terms that would make the expression 0, denominator 0, would be b can't be equal to 3 or negative 1. Start reducing what we can reduce. B plus 1 cancels b plus 1. B minus 3 cancels b minus 3. And 4 cancels with 4. What we're left with is b minus 4 with b not equal to 3 or negative 1. Number 5, again, we're factoring. It's a fraction divided by a fraction this time, so we're still going to factor first. Pull out an 8, so we're getting x plus 2 here over 8x times, remember with division of a fraction, you're going to take the fraction that comes after the division sign and flip it. Take the reciprocal of 8 over 8x, which is 8x over 8. In this case, our only restriction is 8. X can't be 0, because if x is 0, then the number is 0, and it's undefined. And now we just have to cancel out. 8 cancels 8. 8 cancels 8. X cancels x, and we're left with x plus 2 with x not equal to 0. Last one. X minus 2 over 3x. Again, it's division, so we're going to flip the fraction coming after here and multiply. So this 3x squared minus 21x is going to go into the numerator. And I'm going to pull out an x, or 3x, and what I'm left with is x minus 7. X squared minus 16x plus 63 is going to factor as x minus 7 times x minus 9. Our restrictions, x can't be 0. That comes from there. X can't be positive 7. X can't be 9. And in the numerator, it's also 3x times x minus 7. X can't be 0. X can't be 7. We've already accounted for those from the denominator. Start factoring out what we can factor, or crossing out what we cancel. 3x cancels 3x. X minus 7 cancels x minus 7. And what we're left with is x minus 2 over x minus 9. With our restrictions, x can't be 0, 7, or 9. Okay, so for these 4 problems simplifying the expressions, these are all fractions. So in order to add or subtract fractions, you must find the LCD. Now, LCD is pretty easy to do. You just make sure the bottom is factored, the denominator is factored, and you look at the terms that are there, and you get the greatest power of each factor in the denominators. Okay, so for this first one, the LCD is going to be n minus 1 times n plus 1. So looking at this first fraction, this one, the denominator n minus 1, it doesn't have an n plus 1, so we're going to multiply top and bottom by n plus 1. Remember, when you multiply the top and the bottom of a fraction, it's like multiplying by 1, so it doesn't change it, just changes its look. Okay, the second one, n plus 1, it's missing n minus 1, so we multiply top and bottom by n minus 1. Okay, so 6n times n plus 1 is 6n squared plus 6n over our LCD minus 5 times n minus 1 is 5n minus 5. And I'm putting this in parentheses to account for this subtraction sign between the fractions. And again, all this over the LCD. Okay, so we need to subtract this first fraction from this, or the second fraction from the first fraction. Okay, so we have 1 6n squared. We have one n squared term, so that's just going to be 6n squared. We have 6n minus 5n, which gives us positive 6n. And we have minus negative 5, which is positive 5, over our LCD of n minus 1 times n plus 1. Okay, so we got to look in does 6n squared plus n plus 5 factor, just in case it would factor, well, we can cancel something from the denominator. Looking at the magic number, which is 6 times 5, positive 30, there are no factors of positive 30 that add up to positive 1, so this is done right there. Okay, problem number 8. Again, this guy, the LCD, is going to be equal to k minus 5 times k plus 5. Okay, so we're going to multiply this guy by k plus 5 over k plus 5, and this guy by k minus 5 over k minus 5. Okay, so 5 times k plus 5 gives us 5k plus 25 over our LCD, plus 6k minus 30. 6k minus 30 over our LCD. 5k plus 6k is 11k. 25 plus negative 30 is minus 5 over k minus 5, k plus 5. Okay, nothing factors out of the numerator where we could cancel with the denominator, so we're done. And all these on this page just say simplify each expression, so we don't have to look for restrictions on the variable. Okay, so number 9, this one. We're looking at the denominator, and we need to factor this. So x plus 5, this is going to factor as 3 times x plus 5 minus 4 over 2. Now we got a couple of options here. We could make this really simple for ourselves and recognize that x plus 5 and x plus 5 cancels out, giving us 1/3 for this first denominator. So we're getting 1/3 minus 4/2, which is 2. Agreed. So we just need to figure out what is 1/3 minus 6/3, right? Because we multiply this by 3 over 3. Okay, so 1/3 minus 6/3 is negative 5/3. And we're done. Okay. This next problem, again, we want a factor. So 2x plus 6 over, we can pull out a 2x here, and this is going to give us x minus 4 plus 5x over 3. So in this case, we can't really cancel anything out. Nothing's really going to cancel out, so we have to find the LCD. LCD is going to be 3 times 2, which is 6x times x minus 4, or 2 times 3 times x minus 4. Okay, so in this first fraction, the only thing that's missing is a 3. In this guy, we're missing 2x times x minus 4. Okay, so this is a 3. Okay, so here we're getting 6x plus 18 over our LCD. And here we're getting more stuff, because we're getting 10x squared plus 8 plus 6 plus 18 over 10x 10x squared times x minus 4. So 10x cubed, 10x cubed minus 20x squared all over our LCD. So we need to get together what we can get together. Okay, so I'm going to write it up in this area up here because I'm running out of room. Okay, so what we're going to get is 10x cubed minus 20x squared plus 6x plus 18 all over our LCD of 6x times x minus 4. Okay, so looking at this numerator part, can we get this to factor at all? That would make something nice for us, and we really don't. So we wouldn't get anything that would help us out factoring wise, so we would just leave it right like that, this big ugly mess of polynomial. There we go. Number 11, here we have a compound fraction, right? So basically what we have are, we want to write this as a fraction over a fraction. So I always find it easiest to deal with just one of these at a time. So we're looking just at the numerator. We're getting x minus 5 over 5 plus x minus 5 over 3x. So for this one, our LCD would be 15x, or 3 times 5 times x, right? So this first one has the 5, but we need the 3x, so we're going to multiply top and bottom by 3x. This guy has 3x, but we're going to multiply top and bottom by 5. When we do that, we're getting 3x squared minus 15x over our LCD plus 5x minus 25 over our LCD. We need to combine all this stuff together. So 3x squared, negative 15x plus 5x is negative 10x minus 25. So again, we got to look at this. Our magic number is 3 times negative 25, which is negative 75. Are there factors of negative 75 that add up to negative 10? And they are. We get negative 15 and positive 5. 15 times 5 is 75. So this is going to factor as 3x squared minus 15x plus 5x minus 25. I'm still working on just the numerator here, and this is actually just the top part of the numerator, this top fraction. Grouping these guys, 3x times x minus 5. Here, pulling out a positive 5, we're going to get x minus 5. So this thing is going to factor as x minus 5 times 3x plus 5 over our LCD, which is 15x. So all this is what we get from there. Okay, now we got to work on the bottom part. I'm going to put the bottom in blue. Okay, so here we have 1/3 minus x over 9. So our common denominator here would be 9, right? So we can just multiply this first one by 3 over 3, which would give us 3/9 minus x over 9, which is going to be 3 minus x over 9. Okay, so if we have this is the top fraction and this is the bottom fraction, so what we're getting is x minus 5 times 3x plus 5 all over 15x and this over this, 3 minus x over 9. So now we have a fraction divided by a fraction. It's just a big ugly fraction divided by a not quite as big an ugly fraction. But we're going to get x minus 5 times 3x plus 5 over 15x times, now we're going to flip this guy, 9 over 3 minus x. The only thing we can really cancel here is 9 and 15 both have a common factor of 3. So we can factor that out, and we're going to get 3 fifths. And then so our final answer would be this. I'm going to put the 3 in front because it's going to look better out there. X minus 5 times 3x plus 5. All this over, what are we getting? 5x times 3 minus x. And you can leave it right like that. There you go. We can recognize it. Okay, so for these guys, these are now equations. You can tell because it has the equal sign. Okay, equations involving rational expressions. So what we want to do, like we've done on all of these, is factor the denominators. Okay, so the denominators are all factored, and what the LCD is this. It's going to be 3v times v minus 6. Okay? Now, in order to get rid of or clear the denominator, is we're going to multiply each term, the entire thing, by the LCD, which is 3v times v minus 6. 3v times v minus 6. Okay, so 3v times v minus 6 on this first one. The v minus 6 cancels out with that one, so we're just getting 3v in the numerator. The denominator is gone. Okay, minus in this one, the 3 and the v minus 6 is going to cancel out, so we're going to get minus 5v. And then here, the entire denominator cancels out, so we get v minus 4. Okay. Any restrictions on the variable? Yes, there are. V can't be equal to 0 or positive 6. Now let's just solve for v. So 3v minus 5v is negative 2v is equal to v minus 4. Subtract v from both sides. Negative 3v equals negative 4. Divide both sides by negative 3. V equals positive 4/3. And if you pop that back in there, it works quite nicely. Remember, our restrictions were just 0 and 6, so that should be fine. This next one, again, we're gonna factor the denominator. A squared plus a becomes a times a plus 1 plus 4a plus 12 over a equals a plus 5 over a. Now what's the least common denominator? The LCD is equal to a times a plus 1. To get rid of the denominators, to clear the denominators, we multiply each term by a times a plus 1, which is the LCD. So a times a plus 1 to this term, that cancels out, we get 1. A times a plus 1 here, the a cancels out, and we get 4a plus 12 times a plus 1. We need to factor or to FOIL that thing out. And this guy, the a cancels out, and we're going to get a plus 5 times 4a plus 1. Again, we need to follow that out because we got to put terms together. Okay. So 1, multiplying this thing out, 4a times a is 4a squared. 4a times 1 is 4a. 12 times a is 12a. So 4a and 12a is positive 16a plus 12. And over here we're getting a times a is a squared plus 1a plus 5a gives us 6a plus 5. Now we just need to get everything together. It's quadratic, so we're going to set it equal to 0. So I'm going to subtract a squared from both sides. Okay, that cancels out. This is going to give us 3a squared. I'm going to subtract 6a from both sides. That cancels out. And this gives us positive 10a. Then I'm subtracting 5 from both sides. That cancels out. Minus 5, 12 minus 5 is 7, plus this 1 over here is positive 8, equals 0. Now, we need to figure out, does this thing factor? So 3 times 8 is 24, so magic number is 24. Are there factors of 24 that add up to 10? And there are. Okay, 6 and 4, so 3a squared plus 6a plus 4a plus 8 equals 0. Factor this guy out, we pull out 3a. Now we're going to group the first two and the second two till you do magic number. So we pull 3 out, we get a plus 2. Pull here, pull out a 4 out, we get a plus 2 equals 0. So 3a plus 4 times a plus 2 equals 0, meaning a is equal to negative 4/3, or a is equal to negative 2. Now, do we have any restrictions on our variable from way back with the LCD? Do we? Well, a can't be 0, and a can't be negative 1. Is this arguably 0 or negative 1? Nope. So we're good. Okay, now we're dealing with radical expression. So number 14, this is the cube root of 162 x to the 4th y to the 6th. In order to get stuff out from under the radical, which in this case is a cube, we want to be able to express these things as something to the 3rd power. So first, this 162, that's like 2 times 81, right? 2 times 81 is like 2 times 9 times 9, or 2 times 3 cubed times 3 times x to the 3rd times x times y squared cubed. Now notice I'm putting in everything in terms of cubes that I can. Okay, so going through this stuff, 2 cube root of 2 is just cube 2 that stays inside. The cube root of 3 cubed, 3 cubed, the cube root of 3 cubed is 3, so it comes out from under the radical. Okay, 2 stays in, 3 stays in. X cubed can come out as x. X stays in. Y squared cubed comes out as y squared, and then everything that's under the radical, 2, 3, and x, 2 times 3 is 6, is x. So we get this for our simplest radical form of cube root of 162 x to the 4th y to the 6th. Okay? All right. This one, again, we want to express these guys in terms of this time squares, because when there's no index listed, it's the square root. So 8 is 2 cubed, which is like 2 squared times 2. X cubed is like x squared times x, and then times y. So the square root of 2 squared is 2. That can come out. 2 stays in. The square root of x squared is x. That comes out. X stays in. Y stays in. So we're getting 2x times the square root of 2xy. got that. Okay, so in this one it says simplify, your answer should contain only positive exponents, meaning we have to get rid of these negative exponents. We got to go these things in order. Okay, so this monomial raised to the second power means we're squaring everything in here. So this m to the minus 4 is just going to stay. Okay, and in the parentheses we're going to get m to the 4th n to the minus 10. Agreed? Agreed. Okay, so m to the minus 4 times m to the 4th would be n to the 0 power, which means these guys just cancel out. So we're getting n to the minus 10, but it says your answer can only contain positive exponents. So how do we get rid of this negative exponent? We take the reciprocal of n, which is 1 over n to the 10th power, and we're done. Okay, same thing with this guy. We have this x to the minus 4, y to the minus 2, both of those things squared. So we're going to raise both these guys. Okay, square both these. So this will be x to the negative 8, y to the negative 2, times y cubed. So x to the negative 8th is just x to the negative 8th. Can't do anything there. But we have y to the minus 2 times y to the 3rd, which is going to give us y to the 3 minus 2, or y. We're close, but we can't have negative exponents. So this x to the minus 8th becomes 1 over x to the 8th times y, or y over x to the 8th power. And we're done. Okay, for these guys, when we're solving radical equations, what you want to do is get rid of the radical. In this case, we have n minus 1 equals the square root of 4n minus 8. So if we square both sides of this, n minus 1 squared is going to give us n squared minus 2n plus 1 equals the radicand, which is just 4n minus 8. Remember, this square and the square root are going to cancel out. You're going to get left the radicand. This is now quadratic in the left-hand side, so I'm going to subtract 4n from both sides, and I'm going to add 8 to both sides, giving us n squared minus 6n plus 9 equals 0. And then we just factor this and solve for n. So this is going to give us n minus 3 times n minus 3 equals 0, meaning n must be equal to 3. But we should probably check our answer. So 4 times 3 is 12, minus 8 is 4, and the square root of 4 is 2. On this side, 3 minus 1 is 2. Since 2 equals 2, our answer checks. Lovely. Okay, 19, same thing. We're going to square both sides. Okay, n minus 2 squared becomes n squared minus 4n plus 4 is equal to the square root of 5n minus 14 squared is just 5n minus 14. The radical and the square root and the square power cancels out, and we're left with the radicand. Again, getting rid of this stuff, right? Getting it equal to 0, so subtracting 5n from both sides, adding 14 to both sides, we're going to get n squared minus 9n plus 18 equals 0. Does this factor? Yes, it does. As n minus 6 times n minus 3 equals 0. So n equals positive 6, or n equals 3. We'll just check that. Okay, so when n is 6, 5 times 6 is 30, minus 14 is 16, square root of 16 is 4, and 6 minus 2 is 4, so this one works. If n is 3, 5 minus 3 is 15, minus 14 is 1, the square root of 1 is 1, and on the left-hand side, 3 minus 2 is also 1, so both of these guys work, and our answer checks. Okay, writing in exponential form. So remember in this case, we have this 10n is under the radical. So that's going to stay as 10n all together. The index on the radical becomes the denominator of our fractional exponent, and the power becomes the numerator. So this is going to become 10n to the 5/4 power. Similarly, number 21, 2b is under the radical, so that's going to stay together. The power is 2, the index is 3, so this is 2b to the 2/3 power. And we got those guys done relatively easily. Going the other way, when we have a monomial to a fractional exponent or a rational exponent. In this case, this 6p is going to stay under the radical. The denominator, 3, becomes the index on the radical, and the power is what you're raising the entire thing to. Okay? So, number 23, same idea. Okay? 2a is going to stay in under the radical. The denominator of our fractional exponent becomes the index, which is 2, so it's a square root. And all of this becomes, or the numerator becomes the power. All of this raised to the power. Now, you could also write this as the cube root of 6p squared. This would be an equivalent expression. It wouldn't make any difference at all. Or this one could be written as the square root of 2a cubed. More traditionally, it's written like this, okay, with the radical being raised to the power, but writing it this way is not incorrect. It's just not done as often. Okay, so for these guys, we have equations involving rational exponents. So just like with the radicals, just like with any of these things, we want to get this term all by itself first. So I'm going to subtract 10 from both sides, giving us 6 equals k to the 1/2 power. Okay, we don't want k to the 1/2. We want k. So I'm going to square both sides. So I'm raising k to the 1/2 to the reciprocal power of 1/2, which is 2, and I'm doing that to both sides of the equation. K to the 1/2 squared is just k. We got rid of the exponent on our variable. 6 squared is 36, and we have our answer. If we were to put this in, k is 36. 36 to 1/2 power is like the square root of 36, which is 6, plus 10 is 16, and 16 equals 16, so we're good. This one, same idea, 25. We're going to subtract 4 from both sides, giving us r to the 1/2 equals 12 minus 4 is 8. Okay, we want to raise both sides to the reciprocal 1/2, which is 2. So r equals 64. If we pop that in there, right, 64 to the 1/2 power, 64, square root of 64 is 8, plus 4 is 12, so this answer checks out. Okay, now these were relatively simple because it was 1/2 to both of them, but whatever that fractional exponent is, if you had it down to x to the 3/2 power, you would raise both sides to the reciprocal 3/2, which is 2/3. Okay, or if it was whatever to the 5/4 power, the reciprocal of 5/4 is 4/5, so we would write it to the 4/5 power. Once you get the term containing that rational exponent by itself, raise both sides to the reciprocal power, and then see what you get. Okay? Good luck.